Alright, if anyone noticed, we did skip a lesson there, and I'll come back to that later. Right now, we just finished covering gravitational potential energy, and that's the energy you could do if an object moved. Well, that leads into the next one, which is what happens when an object does move. When an object moves, it's referred to as kinetic energy, energy of movement. So, definition we have there, kinetic energy is due to the motion of an object, and it depends on two factors, how heavy the object is and the velocity of the object. Think about an empty shopping cart rolling down a Walmart parking lot. You know, if that were to hit another car, might put a small dent or a scratch in the car. Versus think of a car rolling down Walmart parking lot and hitting another car. Now they could both travel the same velocity, but because of the heavier mass of the car, it would cause more damage than a shopping cart. The formula we use is EK equals half mv squared. So potential energy due to gravity is Eg. Kinetic energy is Ek. So remember the two differences, and because the formulas are completely different. The mass should always be in kilograms and velocity in meter per second. And the unit for energy, there's no change for that as well. That's the joule. So since velocity is squared in the formula, if anyone looking here, velocity gets squared. The more the object changes, the more effect it's going to have, because you're going to square that number first. So if we look at an example here, if the velocity of an object increases by 3 times, its kinetic energy would increase by 9. It's a square factor, what that's referred to as. So if we kept all things the same, and the mass of an object and its velocity first was 3 meters per second. Well, what this is telling you is that this number is squared. So actually what happens is that you use a 9 in the formula instead. So it has a bigger effect if you change the velocity than if you change the mass. Oops. That's a 2. And this little diagram here is a nice little way to summarize potential energy and kinetic energy. Lift the mass up, it has the potential to do work, but as soon as the mass drops, the potential energy changes into kinetic energy. So this is energy of movement. This potential energy is only due to position. So potential energy is due to position. Kinetic energy has to deal with the motion. Now there's going to be several examples here for you to do. I want you to work through them, try them yourself, and then I'll bring up the answers after you have time to look through them. And again, when I return to class, if you have any questions on it, let me know and we'll go through it together. And again, folks, this is to prepare you for a larger review sheet that I want you to do. So curling stone has a mass of 6.36 kilograms and slides at 1.5 meters along the ice. Find its kinetic energy. Now assuming you pause the video, the answer would be half mv squared. So half times mass times velocity squared. Remember, squaring gets done first. Don't multiply everything out, then square it. Square the 1.5 first, and you should come back with 7.15 joules. And if the velocity were increased to 3 meters per second, what would be its kinetic energy? So just between the two questions, if we double the velocity, what happens to the amount of kinetic energy? Now, okay, that's joules. You doubled the velocity was doubled, but the energy didn't double. The energy went up by a factor of 4, and the reason being because it's a square factor, because you're squaring this number here, the 1.5, and a 3. See, you're doubling it, and that's getting squared, which means it's going to get 4 times greater. And compare change in velocity for both parts, or change in kinetic energy. Second velocity divided by the first one. Let's just compare them. 3 divided by 2. The velocity was doubled 2 times. And the amount of energy, it went up to 28.62. It was originally 7.15. So it went by 4 times. So that's what I'm talking about. That when you change the velocity, it's going to have that much greater of an effect on the amount of energy delivered. So a loaded cart of books with a mass of 25.5 kilograms is rolling across the floor. If the kinetic energy is 2,500 joules, what's the velocity of the cart? So here you need to work the equation backwards. So if your formula is kinetic energy, it's equal to a half mv squared. Solve for v. You can put your numbers in first and then solve, or change your formula around first. If you want to change your formula around first, get rid of this half. And several of you are probably going to say, maybe Naomi is saying it, multiply both sides by 2. And that will get rid of your half. And now solve for the velocity. Divide both, so you need to get rid of the m. And then you're left with this. V squared equals 2 times your energy divided by mass. And then how do you get rid of this square? By taking the square root of the entire answer. That will get rid of your square. So if you want to solve by putting your numbers in first, it's a half times the mass, which will be 12.75. Divide both sides by 12.75, and this is what you would get. 200, and then take square root. The kinetic energy of a speeding bullet is estimated to be 2,640 joules. You give them the mass of the bullet, find its speed. So you give them the kinetic energy. So again, find the speed. Multiply both sides by 2. And you get rid of the half on this side. So if you multiply both sides by 2, because it's a denominator, you end up with this. Now you need to get the mass, get rid of the mass. Since you're multiplying, you divide. Divide both sides by the mass. Your formula becomes this. And then to get rid of the square, you take the square root of what you had there before. There is one other little twist to this question. The mass of the bullet is given in grams. You need to change that to kilograms. And this, going through the steps here, what I just spoke about. Divide your 32.5 grams by 1,000 to get the kilograms. And we take square root. You have your velocity. A truck with certain mass is moving at 5 meters per second. Has a kinetic energy of 45,000 joules, or 4.5 times 10 to the 4. The truck accelerates to 15 meters per second, and at the same time, the truck's load falls. The sum of the truck load fall from the back of the truck. So you speed up, stuff falls out the back of the truck. Because of that, the mass of the truck is now reduced by half. So what's the kinetic energy of the truck? Well, we're going to solve this in a couple of parts here. First, before it starts to accelerate, the truck's moving at 5 meters per second. So we can find the kinetic energy. We know it's 45,000. Half is already there, it's part of the formula. We know the speed, but we don't know the mass. So let's get the mass of the truck. So to get rid of the half, multiply both sides by 2, and the 4.5 becomes 9. 5 squared becomes 25. Divide both sides by 25, and the mass of the truck is 3,600 kilograms. Now, someone steps on the gas, the truck accelerates up to 15 meters per second. How much kinetic energy does it have then? So after it accelerates, how much kinetic energy? Well, it's half times mass times velocity. We know the velocity becomes 15 meters per second. The mass of the truck, this is where you need to read your question carefully. The mass becomes reduced by half. So instead of 3,600, it's half of that, 1,800. And that should be 2.0 times 10. It seems to be left out there. 1, 2, 3, 4, 5. 2.0 times 10 to the 5 joules. And if you want to compare the differences, the velocity becomes 3 times faster. It ended at 15 meters per second. It started at 5. 15 divided by 5, the truck was going 3 times faster. Its mass is reduced by half. So the initial kinetic energy was 45,000 joules. Its final energy was 200,000 joules. So your final kinetic energy divided by your beginning, its kinetic energy is 4.5 times greater. So let me go back to that. The point of that question is that when you increase the velocity of an object, you do get more kinetic energy, even though the mass was reduced by half. It's just that the velocity is being squared, so that had a bigger effect on it. Okay, last question. Hot Wheels car, and that's my Hot Wheels track there. I didn't play with small cars, I have them big. So Hot Wheels car is moving at 3.4 meters per second along a track. If the car has, it tells you how much potential energy there, or kinetic energy, sorry, what's the mass of the car? Well, kinetic energy, half mv squared. So find the mass. Get rid of the half, multiply both sides by 2. So I want to get rid of the velocity here, divide both sides by the velocity. It's gone. So this is the part you need to carry out. So you can put your numbers in first if that's the way you rather do it. Do your squaring of your velocity, then multiply that by half. And you're left with 5.75. Now don't get mixed up here. That's not 5.75 meters. That's your mass. And divide both sides by that number. So the mass of your little dinky on your Hot Wheels track is 0.1 kilograms, or 100 grams. And 6, calculate kinetic energy of a 15,000-pound army tank charging forward at 100 kilometers an hour. Now, there's a little trick to this one. Try and solve it first, but a little heads up. Okay, so I'm going to assume that the video is paused and you gave this a try. Your velocity should be in meters per second. So to change 100, if you remember to go from kilometers per hour to go from kilometers per hour to meters per second, you have to take your kilometers per hour and divide by 3.6. If you're going the opposite way, meters per second to kilometers per hour, you will multiply by 3.6. Now, we're probably not going to do very much of that here in this course because we need everything in meters per second. So this is the part you really need to concentrate on. When you go from kilometers per hour to meters per second, divide by 3.6. And then it's straightforward calculations. Oh, I lied. There's one more question. Sorry, guys. Find the kinetic energy of a bullet traveling at 3,600 kilometers per hour. So here you need to change both your mass and the velocity of the bullet. So when you change both, you should work your kinetic energy out to 12,500 joules. Or by rounding it, 1.3 times 10 to the 4. Remember, you're moving a decimal from the end to behind the 1. So 1, 2, 3, 4. Now, how fast would a 13,000-pound truck have to be moving to have the same amount of energy as the bullet? So if you want a 13,000-pound truck, say a small moving truck, to have the same kinetic energy as that bullet, how fast does the truck have to be traveling? So I want you to find the velocity. So input the numbers that you have, multiply this by half, then you're going to divide by the 6,500, and take square root, and the truck has to travel at 1.4 meters per second, and if you multiply that by 3.6, it has to move, say, roughly between 5 and 6 kilometers an hour. So how many times faster must the truck go to quadruple its energy? So if you want the truck to have 4 times the amount of energy, how much faster does it have to go? Well, you want it to quadruple. So you want it to go up by a factor of 4. So what has to happen is that velocity has to double. Again, that's that squaring factor where it's kicking in here. Now if you're not sure on that, just go back. Let me do this faster. Go back to the beginning. And it's the opposite of what we were doing here. So what would the velocity have to be to get the energy? So if we wanted the energy to quadruple, it has to go twice as fast. So it's the opposite really of this of the last part of question 1. Anyway, that's it, guys. If there's any other questions, I'll take care of them when I come back. And again, I'll make it up to you guys when I come back to class on Thursday.